Hello, my name is Efe. We will present our project Agri, which is a solar-assisted agricultural spraying robot with my teammates Melik and Emre. Agricultural spraying often exposes humans to harmful chemicals, and our main goal is to reduce direct human involvement during spraying operations. Our design is a simple and low-cost system which allows the user to control movement and spraying remotely. In addition, solar energy is integrated to support the battery and extend operating time. The mechanical structure of the robot was designed using SolidWorks. An aluminum frame combined with a plexiglass base plate was used to provide mechanical strength while reducing overall weight. 3D printed motor wheel joint was used to ensure proper connection between the DC motors and the wheels, and then aluminum support rod was added to increase spraying height. In total, the system consists of 38 integrated mechanical and electronic components.
And here is the exposed view. We use the modular design for easier maintenance of our parts, so we can detach and attach our parts easier. And in our energy analysis, we plotted out the battery life with or without the solar panel. And our battery has a maximum voltage of 12.6 voltage output and minimum voltage of 9.6. And if we go lower than the critical voltage, we actually can't charge the battery. So that's important. And our battery can gain runtime extension of 16 minutes with solar panel. And in this plot, we used water jet projection animation. And for this one, we actually made some theoretical calculations. And after making these theoretical calculations, we compared to our experimental data, which was about maximum reach of 100 centimeters. And with an adjustable speed, as you can see as the animation, our water pesticide spraying actually works that way as well. And in our process flow diagram, we can see our electronical components and how they are connected. We mainly use two L298 and drivers and one Arduino Uno R4 Wi-Fi, which allows us to connect to the cloud to control the system. And the solar panel via battery management system allows us to charge the battery.
To compare Hi everyone, it's Emre. To compare the theoretical designs and experimental results, we used ANSYS and did a static structural analysis on the plastic that joins the wheel and motor. We applied 15 Newton on it, which is almost equal to divide 4 of our robot's kilogram. After that, observed the deformation, and the total deformation is about 9 Newton meter, which is pretty negligible and almost impossible to detect. It means our PLA design is pretty applicable. Here are some videos. On the left one, you can see the moving straight forward and straight back mechanism of robot, and the middle one, there is a 360 degree of rotation around axis facility, and right one shows the spraying mechanism. Thanks to the solar panel, we gained more than 15 additional running minutes. And since the robot is mobile and work by remote, the user doesn't have to go to the field area and spray by itself. Instead, he or she can just run the machine by far, so that wouldn't be affected by the poison of pesticides. Lastly, we validated that our 3D PLA design works well for the project by using ANSYS analysis. There are some potential works, for instance, integrating a camera that uses image processing and detects the plants and spray them by itself, or adding a motor that changes the position of nozzle. Lastly, although we used plastic wheels, we can replace it with pneumatic wheels, which is more fit to agricultural conditions. We would like to thank our TAs, Barzoki, Yiğit, and Mr. Türkel'de, Mr. Tulay. Here is our references. Thank you for listening.